Hi there and welcome to Hegarty Maths. It's Mr. Arnold here, and in this video we're going to be looking at some core maths techniques, namely sketching functions. And in this video I'm really going to focus on cubic functions. Cubic functions are given in the form ax cubed plus bx squared plus cx plus d. They're called cubic functions because the highest power of x is a cube. And I'll just do a quick sketch of what the most basic cubic function is. Y equals x cubed. And it looks something like this, where it comes up and it will just pass through 0, 0 and then head off up to infinity like that. So that's the general shape of a cubic function. We also have other shapes, such as this, where it comes up, passes down and goes off up to infinity like that, or it can come down, go up and then back down again. Now this version here on the left happens when the coefficient of x cubed is positive. And this one here happens when the coefficient of x cubed is negative. So very much in the same way, when we're dealing with quadratics, if the coefficient of x squared is negative, we end up with a n shape, and when it's positive we end up with a u shape. It's very much in the same idea. And then one other thing that we need to be aware of, and this shouldn't be any surprise when dealing with cubic functions, if I let x equal 0, that will give me the y-intercept. So if I let x equal 0, we get the y-intercept, or where it cuts the y-axis. And similarly, if I let y equal 0, that will give me the x-intercept. Okay, let's have a look at a few questions now, see how we go. Right, suppose I have this function here and I was asked to sketch it. How do I know it's a cubic function? Well, I'm going to have x times x times x, which will give me an x cubed. Just in case you're wondering, if you were to expand this out, you would get x cubed minus 2x squared minus x plus 2. But kindly, it's been factorized here for us already, so that makes it a lot easier to sketch. Okay, so set of axes. We should really label the axes. We would have as the x-axis and this is the y-axis. Okay. Now the first thing to think about is if y was equal to 0, we would have x minus 2 times x minus 1 times x plus 1. So we have a product of 3 terms, gives an answer of 0. That means 1 or all of those terms are equal to 0. Well, if x was 2, this part would be 0. So when x equals 2, y equals 0. When x equals 1, y will also equal 0. And when x equals negative 1, y will equal 0. So these are really useful. They tell me where the function cuts the x-axis. In other words, where y is equal to 0. So we had x equal to 1, x equal to 2, and x equal to negative 1. So that's the first part. The next thing I'd like to know is where does it cut the y-axis? So where does it cut the y-axis? It will cut the y-axis when x equals 0. So we end up with this. These are the x-intercepts. And then we want the y-intercept, or intercepts. There's probably only going to be one. So we let y equal, it's going to be 0 subtract 2 times 0 subtract 1 times 0 plus 1. So we're letting x equal 0 here. We get negative 2 times negative 1, which is positive 2. Positive 2 times 1 is also positive 2. So when x equals 0, y equals 2. So the y-intercept is when x equals 0, y equals 2. Let's go back to our graph. When x equals 0, y equals 2, somewhere around here. And then finally, I just want to think about the shape of the graph. Well, it's positive x cubed, which means that as x gets bigger and bigger and bigger, y will also get bigger and bigger and bigger. So as x goes to infinity, y will also go off to infinity, which means it's heading in that direction, which means it must have come from this direction here. So let's see what we might get. Okay, so we would imagine it would come from that direction. It will go up. It'll cut the x-axis or the y-axis, come back down. It needs to turn again. It needs to turn again in order to get back up here and go off up to infinity. And we've labelled the points at where it's cut the axis. Okay, let's have a look at another one. So we get y equals x minus 2 times 1 minus x times 1 plus x. Okay, I'm just going to make this a little bit more straightforward. Fantastic. Okay, so let's get our axes done. Something like that. Okay, let's go for our x-intercept. X-intercepts at y equals 0. So we get 0 will equal x subtract 2, 1 subtract x, and 1 plus x. So I've got a product of 3 terms multiplied together, and that gives me an answer of 0, which means 1 or all of them must be equal to 0. So how would I make it 0? Well, if x equals 2, y will equal 0, because if this value was 2, 2 subtract 2 is 0, and then 0 times everything else, doesn't matter what it is, will give me 0. X equal to 1, if x was 1, 1 subtract 1, y would equal 0. And also if x equaled negative 1. So if x equaled negative 1, y would equal 0. So these are our 3 points at which it cuts the axes. Let's mark them in. X equal to 1, x equal to 2, and x equal to negative 1. Okay, that's our x-intercept. Let's get the y-intercept. So where does it cut the y-axis? Well, that happens when x equals 0. So go back to the original the original equation, or original function if you will, and substitute x equal to 0 in. So y would equal 0 subtract 2 times 1 subtract 0 times 1 plus 0. And when we work that out, negative 2 times 1 is negative 2, and times that by 1 is also negative 2. So we get a value down here, negative 2. And then finally I need to consider the shape of the graph. Well, this is I'm going to have x times a negative x, which would give me negative x squared, and that negative x squared is going to be timed by x, which would give me a negative x cubed value. I'm going to have negative x cubed, which means it must have come from this direction. So as x gets bigger and bigger and bigger, y is going to head closer and closer and closer to infinity, but in the negative direction. So as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller. So it's going in this direction, which means it must have come from up here. As x gets smaller and smaller and smaller, or more and more negative, y would get more and more positive. Okay, so what will this look like? Well, it's coming from this direction, so it must come down here. It'll pass through that point of intersection, pass through that point of intersection, up here, and then back down through this. So we should have two turning points, and there they are there, and it's heading off into the negative direction. Okay, how about this one? X times x plus 1 times x plus 2. Same idea again. So sketch the axes. Let's go for the y-intercepts. The y-intercept, I mean the x-intercepts, although you could have got the y-intercepts first. Okie doke, and that happens where y equals 0. The x-intercepts are where y equals 0, because everywhere on this axis the value of y is always 0. So 0 would equal x times x plus 1 times x plus 2. So when x equals 0, if this x is 0, all of this becomes 0, and thus we get an answer of 0. So when x is 0, y would equal 0. When x equals negative 1, if I put a negative 1 in here, all of this becomes 0. And when x equals negative 2, y will equal 0. X equals negative 2. So let's plot these. When x equals 0, when x equals negative 1, and when x equals negative 2. Let's go for the y-intercept. Well, the y-intercept, I'm sure you might have noticed, is going to be the same as the x-intercept, but let's just prove it. So the y-intercept is where x equals 0. This is where y equals 0, just in case we didn't have it down earlier, where y equals 0. So going back to our original thing, if x is 0, 0 times all of this is going to give me an answer of 0. So you get 0, 0. Okay, and then finally the shape of the graph. What happens as x gets bigger and bigger and bigger? Well, this is x cubed, positive x cubed. X times x will give me x squared, and when I multiply that by x, I'll get an x cubed term, which is positive, which means as x gets bigger and bigger and bigger, y will also get bigger and bigger and bigger. So it's going to have this shape. It's going in this direction, which means as x gets smaller and smaller and smaller, y must also get smaller and smaller and smaller. So it should have come from this direction. Okie doke. So the graph would have come from this direction, passed through -2, it's got to turn at some point, come back down, go through -1, got to turn at some point, and then come back up through that intercept there and off to infinity. So you've got the general shape of the curve, which means we're good to go. Okay, next one, sketch the following. Again, start with our axes. And let's make life a little bit easier for yourself. Y equals x subtract 1 squared times x plus 2. Well, that's just the same as y equals x subtract 1 times x subtract 1 times x plus 2. So let's go for the x-intercept. So the x-intercepts, let's say where the x-intercepts happen where y equals 0. So we get 0 equals x subtract 1 times x subtract 1 times x plus 2. Okay. So what values of x give me an answer of 0? Well, when x equals 1, all of this would become 0 because we'd have 1 subtract 1, which is 0, and then 0 times the rest is 0. So when x equals 1, y equals 0, we get 0.10, if you will. When x equals 1, y would equal 0, so we get to 0.10. We have a repeated root. And when x equals 2, when x equals -2, y would equal 0, so we get -2 and 0. Let's get these onto our sketch. So when x is 1, y is 0, and when x is -2, y will equal 0. And let's go for the y-intercept. The y-intercept where x equals 0. So if x equals 0, we'd have -1 times, in fact, let's plug it in so that we can see what's going on when x equals 0. So we get y equals 0 subtract 1 times 0 subtract 1 times 0 plus 2. So we get -1 times -1, which is +1. +1 times +2 is +2. So when x equals 0, y will equal 2. Okay, let's go back up to our function. When x equals 0, y will equal 2. So somewhere up here. Okie doke. Now I need to sketch this graph. It's going to have a positive x cubed, which means that as x gets bigger and bigger and bigger, y also gets bigger and bigger and bigger. And if x gets smaller and smaller and smaller, y will also get smaller and smaller and smaller. So it's going in this direction, and it's come from this direction. Okay. Now, we also found that we had a repeated root, which is here. Repeated root. So let's see what it looks like. Well, it must have come from this direction. We've already spoken about that, so it's come up. In fact, let me use a different color. It's come up from this direction. going to turn at some point, and then it's got to come back down through this guy. And because it's repeated, it means it's just going to come down and touch the 1 and then change direction again and go off up to infinity. So it comes up like this. It'll have to turn and pass down through this y-intercept, pass back down, and then just touch the 1 and then go back off up to infinity. And that's why the route is repeated. So we only pass through the x-axis once, and then we come down and we touch it once. We don't pass through it the second time. Okay, one more to go. So we're asked to sketch the following here. It looks quite complex. Let's see what we can do. So, axis sketched. Now, what I'm going to do is, I'm going to make life a little bit easier for myself. I'm going to factor out x. I can see there's an x common to everything, so let's factor out x. And that would leave me with x times x squared, subtract 3x, subtract 10. Now this is looking a little bit more manageable because I think I can factorize what's in the brackets. So, two numbers that multiply to give negative 10 but add to give negative 3. So x in both. And I'm thinking negative 5, positive 2, and then we're golden. Okay, so now we factorized it. Let's decide what the x-intercepts are. So the x-intercepts happen where y is equal to 0, and we get this. So we get 0 equals x times x subtract 5 times x plus 2. So we're substituting y equal to 0 back in here. Okay, so what values of x will make this 0? Well, if x equals 0, so if this x is 0, doesn't matter about the rest, 0 times whatever's here is still going to be 0. So when x is 0, y equals 0. If x equals, if I put a 5 in for x, we get 5 subtract 5, which will make this term 0, which makes the whole lot 0. So if x equals 5, y will equal 0. And then finally, if x equals, if I put negative 2 in for x, y will also equal 0. So these are the points: 0, 0, 5, 0, and negative 2, 0. So plot these points: 5, 0, 0, 0, and negative 2, 0. Don't get hung up on the scale. You don't need to be too particular about the scale. Just try and use a bit of common sense with it. Okay, so that's the x-intercept. Let's do the y-intercept. So the y-intercept occurs where x equals 0. So if we go back up here and substitute, we end up with y equals 0 times 0 subtract 5 times 0 plus 2. And lo and behold, because that part is 0, that means the rest will be 0. So the point is 0, 0. So fairly straightforward. You could see it there. The y-intercept was already given. Okay, last thing to do, decide on the shape. So we can see as the x cubed term is positive, as x goes to infinity, as x gets bigger and bigger and bigger, that means that y will also go to infinity. And as x goes to, let's come down here, as x goes to negative infinity, so as x gets increasingly smaller, that means that y will also get increasingly smaller. In other words, it's heading in this direction and it came from this direction. Okay, so it should have come up like this. It will turn at some point, and then it's got to pass through this guy, and then it's got to turn again and pass through that guy and head off to infinity. And that's a sketch of that graph. That's it for this video. Hopefully you found it useful. I'll be back again with another video soon. All the best with the revision. Take it easy.